Hi guys, in this video, I'm gonna talk about principal component analysis using a real-world dataset. PCA is an unsupervised linear transformation technique that is widely used across different fields such as feature extraction and dimensionality reduction. You can also use PCA for exploratory data analysis, the analysis of genome, and gene expression levels in the field of bioinformatics. If the correlation is very high among your subset of the features, you can use PCA to combine the highly correlated features. PCA determines the data with a smaller number of linearly uncorrelated features. So, using PCA, you can identify patterns in data based on the correlation between features. In short, PCA finds the direction of maximum variance in high-dimensional data and projects them onto a smaller dimensional space. These newly created components are known as principal components. You can see the orthogonal axes in this chart as the directions of maximum variance. To show PCA, I'm gonna use one dataset. You can find the link of this dataset in the description below. To load the dataset, let me import pandas. Import pandas as pd. Now, let's load the dataset using the read CSV method. df equals pd.read_csv. Let me set our dataset wine.data. This dataset no has label. I wanna use the header argument. Header equals none. Okay, our dataset loaded. Let's name the columns. I'm gonna copy the paste the names of columns using columns attribute. You can find the link of this notebook in the description below. Let me show the first 5 rows of the dataset. df.heat. Here you go. Let's take a look at shape of the dataset. df.shape. Here you can see the number of rows and columns. Let's go ahead and process the dataset. First, I'm gonna split the dataset into training and test set. To do this, let me use train test split function. Let's import this function from sklearn.model selection import train test split. Now, let's split the dataset into training and test set. To do this, I'm gonna use the ilog method. First, I wanna create the input variable named x. The first column is our target variable. To create the input variable, I'm gonna select after this column x equals df.ilog square brackets colon comma 1 colon. Scikit-learn likes to work with numpy array. Let me convert this variable into numpy array. To do this, I am gonna use values. Values. Beautiful. I've created the input variable. Now, let's do the same thing for target variable. Y equals df.ilog square brackets colon comma 0 dot values. Awesome. The input and output variables are ready to split. Let's split the dataset into training and test set. X train comma x test y train comma y test equals train test split. I'm gonna pass x comma y. The distribution of subcategory of y variable is unbalanced. Let's look at this. df class label dot value counts. As you can see, the number of classes is different each other. To split dataset as balance, I'm gonna use stratify argument. Stratify equals y, comma. For reproducible output, I'm gonna use random state argument. Let's say 1. Okay, our dataset is ready. Now, let's scale this dataset. To do this, I'm gonna use the standard scaler class. Let me import this class from sklearn.preprocessing import standard scaler. Now, let's get an example from this class. sc equals standard scaler. Let's scale the training set using this example. x train std equals sc dot fit transform. Let me pass x train. Next, let's scale test set. x test std equals sc dot transform. Let me pass x test. Wonderful. Our datasets are ready to analysis. Now, let's create the covariance matrix. Using covariance matrix, we can obtain the eigenvectors and the eigenvalues. You may ask that, what are these values used for? Let me explain. The eigenvectors of the covariance matrix represent the principal components, whereas the corresponding eigenvalues will define their magnitude. Now, let's obtain these values using NumPy. Let me import NumPy. import numpy s and p. To obtain eigenpairs, first I'm gonna create covariance matrix. Co underscore mat equals np dot co. Let me pass x train std. Let me transpose dot t. Okay, I obtained the covariance matrix. Let's calculate the eigenpairs using this matrix. To do this, I'm gonna use linalg method in NumPy. Eigen values eigenvex equals np dot linalg eig. Let me set comat. Beautiful, we computed the eigenpairs. Let's take a look at these variables. First, I wanna see eigenvalues. Eigenvalues. As you can see, eigenvalues consist of 13 values. These values define as the magnitude of the eigenvectors. Let's take a look at the shape of the eigenvectors. Eigenvect dot shape. As you can see, eigenvectors consist of columns in a 13x13 dimensional matrix. We want to reduce the dimension of our dataset, right? To do this, we only select the subset of the eigenvectors that contain most of the information. To see the best magnitude principal components, I need to calculate the variance exponent ratios. The variance exponent ration is computed with this formula. To compute this ratio, let me calculate the total sum of the eigenvalues. Tot equals sum. Let me set eigenvalues. Now, let's calculate the magnitude of each principal component. Var underscore exp equals square brackets parenthesis e tot for e in. Let me sort eigenvalues. Sorted eigenvalues reverse equals true. Okay, I computed the magnitude of each principal components. Let's draw the chart of principal components with explained variance ratio. To do this, I'm gonna use matplotlib. Let me import this library. Import matplotlib dot pyplot as plt. To specify the theme of plot, let me import Seaborn. Import Seaborn as SNS. I'm gonna use the set theme method. SNS dot set underscore theme. Now let's use the RC parameter to set image quality of the plot. SNS dot set. This parameter must be dictionary type. RC equals curly brackets quotation marks figure dot dpi colon, let's say 300. Okay, I specified the theme of the plot. Let's take a look at individual explained variance. To do this, I'm gonna use the bar plot. plt dot bar range 1 14 comma var underscore exp align equals center. Here you go. Wonderful. As you can see, the first principal component alone accounts for about 40% of the variance. We can say that the first two principal components combined explain almost 60% of the variance in the dataset. Now, I am gonna show you how to do PCA in scikit-learn. To show this, let me import PCA class. Let me zoom in. I am gonna set from sklearn decomposition import PCA. Let's get an example from this class. PCA equals PCA. Let me specify two components and underscore component equals 2. Now let's feed and transfer our training data to generate these principal components. Xtrain PCA equals PCA dot fit transform. Let me pass x train std. Okay, I fitted the model and used this model for train data. Now, using this model, I'm gonna transform our test set. X test PCA equals PCA dot transform. Let me pass the x test std. So, I transform our test set. We can see the explain variance. To do this, I'm gonna use explain variance attribute. PCA dot explain variance. You can see the explained variances of the first two principal components. Lastly, to show the power of PCA, let's plot the observation in 2 dimensions. To do this, first I am gonna use for loop. For id x equal cl in enumerate np dot unique yTrain. Let me display a scatter plot of the first and second principal components. Plt dot scatter x equals xtrain pca square brackets ytrain equals cl comma 0 y equals xtrain pca ytrain equals cl comma 1. Let's specify the other arguments. Alpha equals 0.8 label equals I am gonna use fstring class curly brackets cl h color equals black. Now I am gonna give the labels for the access. Plt dot x label pca1 plt dot y label pca2 plt dot legend. Finally, let me set plt dot show. Let me run these codes. Here you go. Here are class 1, class 2 and class 3. As you can see, with just the top two principal components, PCA does a good job of separating the points in space, such that similar points are generally closer to each other than they are to other less similar points. Note that PCA achieves this without using any labels. Now, let's do the same things for test set. Let me copy these codes and paste here. I am gonna change from train to test. Test, 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 test. Okay, let me run these codes. Here you go. As you can see, for test set, similar points are generally closer to each other. Beautiful. PCA is working good for our dataset. That's it. In short, you can use PCA technique to find patterns in data based on the correlation between features. I hope you enjoy it. Thanks for watching. You can find the link of this notebook in the description below. We create the videos about data science, AI, machine learning and deep learning. So don't forget to subscribe to my channel, press the bell icon and give me a like. See you in the next video. Bye for now.